Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard. This is my co-host Nikolai, founder of Postgres AI. Hey Nikolai, how are you doing today?
Hello, doing great. How are you?
I am doing well, thank you very much. Today we're going to talk about buffers. I've got buffers on my mind at the moment. Yeah, and I know this is a topic you care a lot about, and I've enjoyed reading your opinions on them in the past. Yeah, really excited to talk about why they're important. Maybe we can start with what they are, and
You know what?
how
Let's
to
let's
use them.
start let's start from like slightly off topic maybe. You know,
Yeah,
like there is a maybe we will discuss various approaches one day, but there is SQL can be written in uppercase or lowercase or like maybe there are many more options. So I prefer lowercase. I don't because I write a lot of SQL code. So it's like I write SQL code much more than other code like any other language I use over the last many years. And so I don't like to scream and use uppercase at all. But when I type buffers, I enjoy typing the uppercase because
that's so funny.
yeah, because it's so important to use them.
So just to check, do you write explain, open brackets, analyze, comma, and then
Buffers.
caps lock on buffers,
Well,
and then
no, I
continue?
mean, I still use uppercase when I explain things to people, and when you embed small parts of SQL in your regular text, it makes sense to still use uppercase. That's why probably I remember that. Like buffers, I just couple of times per week I explain how important it is to use buffers to other people. So,
Yeah.
and this is
Oh,
the only
but
word I enjoy typing uppercase.
that's so funny. On that, I think I mix my use of lowercase and uppercase all the time. In blog posts, it's really difficult to know. Sometimes it's not clear that you're talking about a keyword or code, and sometimes the code formatting is not great. So yeah, especially when it's inline, I do sometimes use capitals just to show that I'm talking about the keyword, not not just a normal word in the sentence. But yeah, I'm very inconsistent. While we're talking about consistency of how we write things, do you always write Postgres? Sometimes PostgreSQL? Do you have like a rule on which one you write
90%
when?
Postgres, just for
Yeah,
two, eight letters instead of 10, right?
just for the shortness. I find myself doing the same, most probably similar 90%. I tend to use PostgreSQL if like it's a super formal use. So maybe if I'm talking about a version number, in a formal setting, I might say PostgreSQL, but I don't have any better rules than that.
Yeah, I will be trying to pull us to off topics. Like it's so bad that Postgres is 8 letters, not 7, because in California you can have a custom driver license plate, and the limit is 7 letters. So imagine being in the car with a license plate Post Korea without us. It's
Well,
like
so that would be
people
pretty
will kill you,
funny.
right?
Yeah, there are people out there that would see that as a hate crime, I think. Anyway, yes. So, but back to a shorter word, buffers. So we've talked about this before, but what if in case anybody's not sure what we're talking about, this is a measure of, well, I guess it's not quite strictly this, but it's a rough measure of I/O in the query. So in terms of number of blocks being read or written by various parts of the query, and it shows up in multiple places. I'm aware of it being obviously in explain output. So explain or even explain. So explain and analyze mostly, but also now explain as of recent versions, and of course as columns in pgstat statements in terms of telling us how much IO different queries are doing. Are there other places that it's showing up?
Yeah, well, let's explain a little
Yeah.
bit very briefly, because it's very confusing sometimes for new people. Explain is just to check what planner thinks about future query execution, but it does not execute the query. It's only like shows what planar thinks right now for given data, statistics, and parameters of Postgres. Explain analysis for execution. Buffers make sense where? Only in execution, so explain analyze, or in both. It's, I think, like,
So,
like
I know this is a
Postgres
leading question
13,
because I know,
since Postgres
Yeah.
13, it also makes sense for planning stage as well, right? Because it can use some buffers for a planner to make it work, right? Tricky question.
well,
I don't
guess
remember
it's always
100%.
been it's always been possible for the planning stage to read data, but I guess we've not had the ability to ask it how much it's doing before. So
Since Postgres 13 is possible, I guess, right? So there is for planner stage, it also shows how many buffers were hit, read, or and so on, right? And so on. Also tricky. Okay, let's avoid this. Like I'm not prepared to talk about it. But what I also wanted to there are many confusing places in database area in the field in general and Postgres particularly. For example, there is also analyze keyword, which is absolutely another thing. It's command to recalculate statistics. Well, it's not 100% like far from getting the plan, because if you run analyze on a table, you can fix the plan, for example, because you will have fresh statistics. But it can be confusing because analyze after explain means very different thing than analyze a table, right? So it's like basics for people who start with Postgres.
yeah, absolutely. So in probably today we're only going to be talking about analyzing the context of the explain parameter. Yeah.
Right.
Cool. So what is there anything in particular you wanted to make sure where did you want to start with this?
Maybe we should discuss like what 1000 buffers hit or read means, right? But like it's I found working over many years working with various engineers and I like most interesting in this case are backend engineers who are the authors directly or indirectly of SQL. They either write SQL directly or they use some ORM or something that generates SQL. But they have the biggest influence on the result. And I noticed that most of them don't understand they maybe understand, but they don't feel like 1000 buffer hits. What is it, right?
Yeah, awesome. So when we're talking about this, we're saying, let's say I've done explain, analyze on a query that's a bit slower than I'm expecting it to be. And because I've been told I always should use buffers from some helpful people down the years, maybe a blog, maybe they listen to a podcast, and they're now using buffers, but they see under, let's say, an index scan, they see shared hit equals 500, read equals 500. So in total, we've got 500 blocks that are shared hits and 500 blocks that are shared read. And this in total is 1,000 blocks, and these represent each one of these is an 8 kilobyte read. The hits being from Postgres' buffer cache, and the reads being from, maybe from disk, but maybe from the operating system cache. Unfortunately, we don't know which one.
By the way,
yeah,
it would be so great to see, like we have for macro query analysis, pgstat statements, we have extension additional pgstat kcache, which can show you real disk I/O. But for explain, we don't have anything. It would be so good to somehow hack.
Actually, something I forgot to mention was we also have, I've forgotten the actual wording for it. Is it I/O timing? So we can do show I/O timing, or I've forgotten the exact keyword. And
Track
does
IO
that-
timing parameter,
Track IO
in
timing.
but it's not won't show you like number of buffers is amount of work. Somebody mentioned this phrase in Twitter. We had discussion about buffer. Yet another discussion about buffers in Explain on Twitter, and somebody mentioned amount of work. This is exactly like this is great description of this information, and timing is not an amount of work, it's duration of work. Why we are interested in amount of work, we'll discuss it later, right? Because while it's more interesting, maybe more interesting than timing. But what first of all, I pull us a little bit back. I double checked, Explain buffers without analyze. It makes sense. I have Postgres 14, but I believe it's since Postgres 13 when it Explain got this planning stage, and I see buffers hits and reads there. So 1,000 buffers, is it big or not that big? How to feel it? Because developers in mind, they may understand, okay, one buffer is 8 kilobytes. By the way, your article is old school. It says kilobytes in old school way. Kilobytes, it's like, because it's not 1,000, it's 1,024, but it's another off topic. So we have block size 8 kilobytes. Is it big to have 500 hits and 500 reads for buffers?
So
1,000 total.
my arithmetic is awful at this kind of thing. That's one of the reasons why in the tool we make, we display that for people to try and make that easier. But one thing I think really catches people out. So I think I wrote down the example of 100,000 blocks is nearly a gigabyte. So I think it's probably closer to 120,000, 125,000, something like that, is a gigabyte of data. So 1,000 is what? 100 times smaller than that. So we're already talking about, what's that, 10? How many? 100 megabytes? No, I'm awful at arithmetic.
So we take number of blocks, multiply by 8, divide by 1,000. 1,000, of course, 1,000 blocks is 8 megabytes, obviously, right? Just multiply by 8, divide by 1,000. You have megabytes in this case. No? We probably
I think
should
it's more
cut
than
this
that.
part out.
I think it's more than that. But I think this is a great example, right? It's hard. Like you have to think. And why are we having to think?
It's
like,
not
why is it? It could just be displayed there, right?
Okay,
for us.
1 is 8 kilobyte. 10 is
Yes.
80 kilobytes.
Yeah.
100 is 800 kilobytes. 1,000 is just 8 megabytes. It's not that big.
Okay.
It's quite small number, but it depends, of course. If you just need to read very, very small row consisting of couple of numbers,
Yeah.
probably it's too much to deal with 8 megabytes of data, and to have, especially to have 500 reads. It may be too expensive to read small, very tiny row with 2 columns. Both are integer 4, for example, so they both fit 8 bytes only, but it's a different topic. so we, like, it's not that big. But what I'm trying to tell that you're absolutely right. Like, converting to bytes, it encourages engineers to think about, to imagine how big is this data volume. So if they hear to read this couple of rows, we needed to deal with even hitting, not reading, hitting a gigabyte. So it's not. It makes them to think, oh, it's something not optimal is happening here. I should find a better way to improve this query. For example, to have a better index option or something like that. But there is a trick here. When we talk about reads, if we, for example, 1,000 reads of buffers can be converted to 8 megabytes, but 1,000 hits can be tricky because some buffers can be hit multiple times in the buffer pool, right?
Well, yeah, so I think this is contentious. I've chosen to mostly ignore this, and if we get some
Right.
double counting, then actually, in some ways, Postgres is doing duplicate work. Like, there is some duplicate work going on, and if we're using it as a measure of work done, I think it's
Yeah.
okay with the double counting.
I also think it's okay. So we can have stored much less data in memory, but if we need to hit the same buffer multiple times, we still count it like the same way as it would be separate buffers, and we just need to understand how much work we need to do. And so yeah, and it's just a thing that like sometimes like we can imagine the cases when the buffer hits converted to bytes or like to bytes, you can see the amount of work bigger than to be hit, buffers to be hit. It exceeds the buffer pool size, maybe, right?
Well, it could even exceed the amount of data you have in the database. Like it's
Right.
totally possible. I
Theoretically,
think
right.
well, I saw an example. I think it was through test data, but
Uh-huh.
Ryan, did you see the blog post by Ryan Lambert on H3 indexes? One of the
Maybe no.
it's a few weeks back, and it was really interesting to me. Like I didn't know about them. They were a type of geospatial index. I think maybe came out of Uber. I'm not 100% sure. And one of his example query plans, he was doing an aggregation on a lot of the data, I believe, and it was doing something like 39 gigabytes of buffers total. And that's a lot, right? But it really shocked him because his data set he knew was smaller than that.
So,
So
35 gigabytes of buffers or buffer hits.
buffers total.
So buffers work total, because like
Exactly.
if we say some number of bytes of data, it feels like a storage, not amount of work to be done, right?
Yeah, good point.
So like I mean, it can lead to confusion much easier than if compared to the case when we mention hits and reads all the time, buffers hit or buffers read or buffer hits, buffer reads. So
Yeah.
I think we shouldn't omit if we convert to bytes, we shouldn't omit these like action words, right?
That's a good, interesting point. So which ones do you mean? Do you mean like hits and reads, or do you mean make sure we still mention that they are buffers?
Yeah, I mean, if we say number of bytes buffers, we can provoke the confusion to think about it as a number of bytes stored in memory. But if we keep mentioning hits and reads, we avoid this confusion. I think, like maybe it's just some opinion, right?
Yeah, yeah.
Also, your post also mentions other types of buffers, not only shared buffers, but also local and temp, and additional confusion that can be made there because local is used for temporary tables.
Yeah.
temp buffers used are for some other operations, and like it's interesting that it can lead to confusion. But I found like most of the time we just work with shared buffers when we optimize the query, and let's discuss why it's more interesting to focus on buffers than on timing, than on just on timing.
Yes. Yeah. So I did do a blog post on this recently. I'll link it up in the show notes. And this is something I think I learned mostly from listening to you speak in the past. But the people that are super experienced in Postgres performance work do often tell me that they focus a lot on buffers at the start, and it took me a while to really work out why that was. But the super important parts are that timings alone. So if we just get explain, analyze, and don't ask for buffers, there are a few slight issues with that. One is we can ask for the same query plan 100 times and get 100 different durations. There might be a reasonable distribution. You might get some slightly slower ones, some slightly faster ones, and they're mostly around the same time, but it's different each time. That's one flaw. And whereas,
especially if you're not alone on this server, and we almost always we are not alone, right?
Yeah, really good point. Another issue, so conversely, why is it different for buffers? The number of shared hits might change and the number of shared reads might change, but in combination, unless you change something else, chances are if you run the same query 100 times, probably you're going to get those two numbers summed together will sum to the same number each time. So yeah, that is a more consistent number each time than timings, even if the individual numbers there change. So that leads on to kind of issue number 2, which is if you're looking at timings, the first time you run a query, it could be that data might not be cached, and
Cold
as you
cache,
run it
right.
yeah, exactly. It might or it might not, but you don't necessarily know especially that you don't know without buffers information. So timings, you might see that you have to run the query multiple times before you feel confident that it's now probably a warm cache. So timings can fluctuate quite a lot based on the cache state. Again, buffers, whilst the number of hits and reads would change, in the sum of those two won't change depending on the state of the cache. And then the third one I pointed out in this blog post doesn't come up as much, but I think it's quite important that the Postgres query planner is not trying to minimize the number of buffers. What it's trying to do is minimize the amount of time. And sometimes it will pick a plan that is inefficient in terms of buffers if it could make it faster. So the most obvious example of this, I think, maybe the only one, I'm not 100% sure, is through parallelism. So if it can spin up multiple workers to do the work quicker than maybe a slightly less efficient index scan and sequentially scan through the entire table, maybe it will choose to do that, even though on a pure efficiency play, you might have been able to do less work on a single worker. So yeah, I'm not sure I see many examples of that, but it does feel like a flaw of looking at timings alone.
Right. Yeah, exactly. I agree with all points. I also like if you think about time, of course you want to minimize it. This is your final goal. But indeed, if you check the query on a clone, for example, which has different hardware, maybe even a file system and so on, and it makes you think about timing. Like you deal with time, and it doesn't match production, and you think, oh, it's not possible to, like, we need the same level of machine and so on. But then you think state caches, you want to reproduce the cache of state, like, and whole the process becomes very expensive. But it's still possible to make to keep the process cheap. You just need to focus on buffers, forget about timing for a bit, optimize based on the amount of work. And if you think about timing as a final goal, but buffers is what's happening under the hood, it helps you understand the amount of work to be done. And if you optimize we focus on buffer numbers. Of course, we focus on row numbers, but it's like more logical. You have rows, but you don't understand how many row versions were checked and how many dead tuples were removed because explain doesn't show it. But buffers can help you understand the amount of work to be done, and this is exactly what optimization should be about, because any index is a way to reduce I/O. Right, just to reduce the amount of work. Instead of sequential scan, for example, on large table, when we need to read a lot of pages, index helps us to read a few pages and reach the target quicker. So the index is the way to reduce amount of work, and that's why timing is also reduced. It's a consequence. So when you optimize something, analyze a query, optimize it, why to deal with consequences instead of like the core of optimization, the amount of work, so buffers, right?
Well, yeah. So I think I completely agree with you, but I do have a couple of like questions. So I think this makes loads of sense, and I think people really click when they see that, they didn't have an index before, sequential scan, it read 500 megabytes of data maybe. And then when they add an index, it's able to look up the exact same rows in 24 kilobytes or something.
Right. And instead of seeing how timing reduced and thinking, oh, good, but we see how buffers are reduced and understand why timing was also reduced. Like we see the reason of this reduction of timing.
Exactly. I think there's a risk that people think they see an index scan, they think, oh, index is a magic, that's why it's fast. It's like, oh, no, it's not magic. It just lets you look it up much more efficiently and therefore faster. So that's, I think I'm completely with you on that. But where I lose you a little bit is that there are expensive operations that don't report buffers. So, for example, a sort in memory or some aggregations, for example, maybe these would count as CPU intensive rather than I/O, and maybe that's far less often the bottleneck. But we don't get any buffers reported for them if they're done in memory. So I think I like getting both timing and buffers and using them in combination. But yeah, that's the only part that I think
of course, we still have other information in the plan, so we can understand, I/O was quite low, buffers, like 4 buffers hit and that's it, but we have 100 milliseconds, what's happening here, right? It's of course, sometimes, but quite rare. Would you agree? Like most often the reason of slow query is a lot of I/O happening under the hood, right?
Yeah. Well, even with the sort case, right? Like, why is a sort taking so long? It's because you're sorting 1 million rows. And if you could instead sort 10, the first 10 that you need, maybe you're paginating or something, you can get those ordered from an index. You're going to massively reduce the I/O and then therefore not need to sort as many rows in the first place. So even when it's not the bottleneck necessarily, I think it's often the solution. If you sped up that sort of 1 million rows, it's still going to be a lot slower than only fetching and sorting.
Yeah, we also may think about our efficiency in the following way. Like we need to return 25 rows or 10 rows. How many buffers were involved in whole query? And the buffer numbers are reported in a cumulative form, so you can look at the root of the query tree and see the total number for everything included underneath. So the question will be, how many buffers were involved to return our 10 rows? If it's 10 buffers, it's quite good. If it's 1, it's excellent. So means probably we have a small table. We had sequential scan of just one buffer, one page, and all rows happen to be present in this page. So few buffers is good to return 10 rows. Thousand already not so good. Right. We discussed that it's just 8 megabytes, but to return 10 rows, probably it's not that efficient. For example, 10,000, it's already quite a signal that it's a very bad execution of a query. But also, two slightly deeper comments related to explain. It's interesting, like as I mentioned, for pgstat statements, we have pgstat-kcache extension. Unfortunately, not available on most managed Postgres services like RDS, but available for all people who manage Postgres themselves. So this very excellent extension. It adds you information about CPU and real disk I/O, and CPU can even distinguish user and the system CPU time, also context switches. Excellent. But for explain, we don't have it. And simple idea, we could still get this information if we have access to /proc on the host. We know process ID. Even if we have parallel workers, we can extract their process IDs. And we could take very interesting information about real disk I/O happened and also CPU. You mentioned CPU intensive work. It could be present in explain, right? Somehow, maybe I don't know, like, is it an additional extension or something, or maybe like some hacked Postgres and for non-production environments? I think it's quite interesting, the area to explore and improve observability of single query analysis actually, right? And it can be helpful to see that like it's very CPU intensive work. I/O was low, that's why query was slow. You just see how much CPU was spent, or something like this. And of course, real disk I/O, it's also interesting to see. And another thing, more and more, I lack the ability to understand the second best and third best plan in Explain.
Yeah.
You see, because the planner makes the decision based on virtual cost, like something abstract, right? Which is, of course, can be tuned according to parameters like random page cost, sec page cost, and so on. But you can tune costs, and planner never think about how many, what the CPU is used. It doesn't think about it, and how many gigabytes we have doesn't think about it. What?
Well, so it does factor those into the costs, right? Like it does, like CPU tuple cost and things like that. But I think I know what you mean. It doesn't factor in the server parameters.
The planner doesn't know what hardware we have.
Yeah, sure.
And the planner, even we can fool the planner, and we do it for query optimization in non-production environments. So when we have, for example, on production we have almost a terabyte of RAM. On non-production, we don't want to pay for it. We have, for example, I don't know, 32 gigabytes of RAM, and the buffer pool is quite much smaller than on production. It's not a problem. The planner doesn't even look at the shared buffers setting value at all. It only looks at effective cache size. So you can say we have terabyte of memory. So we set like 3/4 of that usual approach. So you trick the planner, and it behaves exactly like on production. It chooses the same plan. But what I'm telling, like sometimes we see, okay, planner thinks this is the best option to execute the query based on cost, which depends on statistics and our settings. But we see a lot of I/O happening. Buffers option shows it. Why? What if we had what else we have on the plate? Planner had on the plate. We don't see it, unfortunately. I've heard Mongo has this capability to explain this and provide the second option as well. So what do we usually do? We apply a trick. We say, okay, we had I don't know, like bitmap scan here. Enable bitmap scan to off, and try to check what other option was. So we put a penalty to bitmap scans, so we see the second possible option, probably second. We're not sure.
Well,
but this is a trick.
That's what I wanted to ask. Like how. I think it's a really difficult problem. I've not looked into it myself, but what do we mean by second best? Do we mean second best
slightly
that's sufficiently different? Like, do we like what if
slightly
it did
worse cost?
Yeah, so I understand what you mean, but I think we might end up with not quite what we wanted. So if we actually want to see what would this do with an index scan of the same table, maybe disabling bitmap scan is the perfect way to go. But what if the second best plan Postgres could have chosen would have been a bitmap scan of a different index? Like, would we want to see that? Or like, right. What if it
Good
just
point.
changed the join order a little bit, or the index scan direction, or like there's so many minor things that it's choosing between.
I agree. But my intent is to understand what were other options, several of them maybe, to understand their costs and their buffer, their I/O as well, and compare.
Yeah.
Sometimes cost can be slightly different. We like on some edge case, but buffers are drastically fewer. Operations we have I/O operations for the second option. So we start thinking maybe we need to adjust our settings for the planner. For example, random page cost default 4 should go down to sequential sec page cost, which is 1. And this like exactly understanding the second option. Okay, maybe you're right. Maybe there are many options in between. So this second, maybe number 10 already. I don't know.
Yeah.
But this is what I lack in Explain. Two
Yeah.
things: real physical operations like CPU and I/O, real disk I/O, and also second, third, other options. What were their costs, right?
Yeah.
So it would be
there's-
good to
I-
like you mentioned somewhere that it's already too complex, too complicated to read, explain. It requires a lot of experience, but it still lacks many interesting points, in my opinion.
I think this is like such an interesting trade-off though, right? Like this takes us on to the last topic I did want to make sure we discussed. And I think Explain, there's like a weird trade-off between being useful for people that are new to Postgres versus being useful for super experienced people. And I'm not sure exactly where we should be drawing that line, or where the people in charge should be drawing that line. And we've talked for quite a while about, defaults and what should be on by default. So Explain itself is fairly simple, but Explain Analyze, once we have timings, the extra, let's say, penalty of also asking for buffers, maybe even verbose, but other parameters, and definitely buffers based on our whole conversation today, should that be on by default, so when anybody asks for Explain Analyze, they also get those buffer statistics. Even if they don't know about them, don't ask for them, you can turn them off maybe if you're an advanced user and you don't want them for some reason, but you have the ability to shape what beginners ask for. So if they're reading some guide from 3 years ago that says use Explain Analyze, then they'll get buffers.
Default is very important. Yeah. Do you have some stats about your users? How many of them have buffers included?
Yeah, last time I checked, it was 95% do include buffers, but 95%.
Wow, that's impressive.
Well, 95% also include verbose. Not the exact same 95%, but almost.
Because I guess your documentation offers it, right?
Not just that we offer it, that our tool does not support the text format of Explain. So automatically, if somebody tries to get Explain, Analyze, and paste it into PG Mustard, it won't. It will tell them we need at minimum format JSON. But by that point, we're also saying, please ask for Explain,
right.
Analyze,
So
buffers
you propose to use it. That's why they use it.
Exactly.
If you check the publicly available plans on Explain Depeche.com, for example, or Dali.com, I'm sure more than 50% will be without buffers, unfortunately, because this is default behavior. And I think, interesting enough, there is a consensus based on what I saw in hackers mailing list. Everyone, I didn't see big objections. Looks like people think that it should be on by default, but still, somehow the patch needs review actually right now. There are several options, several iterations already, and let's include the link also. If someone can do review, it would be great help for community, because I think we should have buffers enabled by default. I hope we convinced people, right? So we convinced that buffers should be used. We said that it's important sometimes to convert numbers to bytes, to have a feeling how big is that for wider audience when making decisions. We discussed some lacking features of Explain that probably are tricky to develop, but still would be good to have. And also we discussed that it's possible to run Explain Analyze with buffers, of course, on a different environment than on production. And in this case, I also would like to mention that our tool, Database Lab Engine, an additional chatbot, which can be executed can be run in Slack or browser. It's called a Jobot. And it also converts to bytes, and it allows you to develop to have a very good workflow of SQL optimization, where you don't touch production.
And it's really
when
cool.
we check the query.
It even estimates how, like, if let's say the timing is 100 milliseconds, it even estimates how much faster that would be on production too, right?
Yeah, well, this is tricky. This option is experimental. It's very tricky to develop. We still don't consider it as like final version, but it's not like very needed. People are fine with just seeing buffers, different timing because different file system, different state of caches and so on. But buffers, if we have this shift in mind to focus on buffers when performing optimization. This is perfect place to play with queries, and Database Lab Engine also provides ability to create an index, not disturbing production and your colleagues. This is very important, and to see if it is helpful to reduce the amount of work, so buffer numbers, and therefore to reduce timing in the end of the day. So like I recommend to checking this on Postgres.ai, and of course pgmustard for understanding plans. I like it's maybe that's it, right? So we discussed quite everything we wanted, right?
Well, yeah. So final thing is, if you or anybody you know, any of your friends are able to review Postgres patches, please do check out the one. At the moment, the way Postgres development works, there's a new version of Postgres due out probably back end of this year, Postgres 15. That's already
beta 2 right now.
Frozen. Yes, so that's already feature freeze. So even if we do manage to get this committed soon, it's still at best will come out in a year, just over a year's time. So even if it makes it into Postgres 16, so these things can take years. So don't expect fast results, but if you can, it'd be wonderful. So thank you.
Current commit fest closes in July 31st, so like in 5 days. So probably
on.
Right, but there will be one more commit fest definitely. So like
I think a couple more
actually
before 16. Yeah.
A few, of course. So
Awesome.
feature freeze happens in spring, right? Like in when? Like I didn't follow for a while. It's in May or in April?
I'm not 100% sure.
March.
Sorry.
Okay, let's avoid guessing. Okay, good. It was interesting, I guess. I hope
so.
Everyone likes our podcast. We need your help. Please like, subscribe, and please share the links in your social networks and groups where you discuss Postgres, database engineering, and so on. Thank you, everyone, for listening.
Thanks so much. See you next week.